Yes, hello everyone, welcome. So we'll start our previous year solution series. Now we're going to start calculus, right? So already we have completed linear algebra, last 10 years solutions of UPSC mathematics optional paper 1. Now we'll start calculus last 10 years solutions, right? So in this video we will solve 2024 solutions of calculus which comes under paper 1, right? Yes. So if you haven't watched linear algebra last 10 years previous year solutions, you just go to the playlist. You'll be having a separate playlist of PYQ solutions. Okay. So in 2024, there are 5 questions from calculus for 70 marks. So again, all are very easy, right? So we'll do all problems. So we'll start our first problem. Okay. So discuss the continuity of the function f of x is equal to 1 divided by 1 minus e power minus 1 by x if x not equal to 0, 0 when x is equal to 0 for all values of x. So first what we'll do is we will check the continuity at 0, right? For all other points it is continuous. Yes or no? Other than 0, the function value itself is defined. Yes or no? So we will check only the continuity at 0 because at 0 the function is breaking, right? Okay. So first what we'll do is we will check continuity. We will check we will check continuity. We will check continuity at x is equal to 0. So we know that f is continuous at x is equal to a. So we know that f of x is continuous. F of x is continuous at x is equal to a. At a, it will be continuous if limiting value is equal to function value, right? So limit x tending to a, f of x is equal to f of a. Now to find limiting value, we say limit exists if LHL and RHL at x is equal to a both exist and both are equal and finite, right? So this limit will exist if LHL is equal to RHL. So what is LHL? So limit s tending to 0 f of a minus h is equal to RHL limit s tending to 0 f of a plus h. So if LHL is equal to RHL, we say limit exists and limiting value is equal to the one which are both equal. If is equal to f of a. If all three are equal, we say f is continuous at x is equal to a. That is LHL, RHL and function value at a all are equal, right? So for this limit to be exist, your LHL RHL has to be equal. So if you are not aware of basics, you just go to the playlist. There will be a calculus playlist. You just go through all the videos of calculus content videos. Okay. Now first what we'll do is we will find left hand limit at x is equal to 0, right? So that is we are here we are checking continuity at 0. That means our x is a. So we will check limit s tending to 0 f of a minus h. This is your LHL. So our a is 0. So it will be f of 0 minus h. We are checking continuity at 0. So a will be 0. So this will be limit s tending to 0 f of minus h. So this will be limit s tending to 0. So f of minus h will be here, right? Because h is tending to 0 from the left. So it will never be equal to 0. It is tending to 0 from the left. If it is equal to 0 only, the output is 0. If not, this is your function value. That is 1 divided by 1 minus e power minus 1 by x. So this is your f of x. In f of x, replace x by minus h. So we will have 1 divided by 1 minus e power 1 by h, right? You just have to replace x by minus h. If you replace x by minus h, minus minus will become plus. So we will have 1 divided by 1 minus e power 1 by h. Now you can see this tends to what? As s tends to 0, this tends to 1 minus e power infinity, right? Because 1 by 0 will tend to infinity, e power infinity will tend to infinity. So this will tend to 1 by infinity and this will tend to 0. So that means your LHL will tend to 0. That is your left hand limit. The left hand limit of the function at 0 is 0, right? Now we will find right hand limit for this function. So we will find RHL, right hand limit at x is equal to 0, so we have limit s tending to 0 f of a plus h. A is 0, so we have limit s tending to 0 f of h. F of h is 1 minus e power minus 1 by h. Now as s tends to 0, this tends to 1 minus, so e 1 by 0 will be infinity. This will tend to 1 divided by 1 minus e power minus infinity, and this e power minus infinity will tend to 0. So we will have 1 minus 0. So this will tend to 1. So your LHL is 0 and your RHL is 1. Now what is the function value at 0? Function value at 0 is 0 because f of 0 is 0. Now we see that, right? Now we see that 1 divided by 1 by 0. 1 by 0 is infinity, e power infinity is infinity, 1 by infinity tends to 0 and will tend to 0. Now we see that your LHL is not equal to RHL. Your LHL is equal to RHL and both has to be equal to function value, but here LHL itself is not equal to RHL. That means what? It is not continuous. It is not continuous. It is not continuous at x is equal to 0. If it is, it will be continuous at x is equal to 0 if your LHL, RHL and f of 0 all are equal to 0. But here you can see your LHL is 0 and RHL is 1. So that means your limit itself is not exist at 0. Limiting value has to be equal to function value. So limit itself is not exist. So that means it is not continuous at 0. So discuss the continuity of the function for all values of x. Now it is not continuous at 0, but all other points it is continuous, right? Because at all other points the function is defined at all its point. Yes or no? If the function is defined at that point, your limiting value will always be equal to the function value also, right? So that means the function is the function the function is continuous for all values of x, for all for all real values of x, except except x is equal to 0. Because at x is equal to 0, it is not continuous because our LHL is not equal to RHL. Uh, but all other points it is continuous, right? Because you have said that it is continuous for all other values of x. uh, why I'm saying it is continuous for all other values of x? Because for all other values of x your limiting value will be equal to the function value because the function is defined at that point, right? Okay, clear, right? The function is defined at that point without any break also, right? Because 0 is the only point that is troubling us. For all other points, for LHL, RHL and your function value all will be equal only because your LHL, RHL also the same function. Yes or no? If x is not equal to 0 means, so let us say if x is equal to 1. At 1, your LHL, RHL both are equal to this only. Because if you put x is, if you are finding limit at x is equal to 1, your LHL will be like 0.999. Same function only because 0.999 is not equal to this function. And what about your RHL? 1.111, 1 point something. Again, 1 point something output also same. So in our case, both the function will be same, LHL and RHL, and limiting value will be equal to the function value at that point also. Very simple, right? So we just say that it is continuous for all values of x except at x is equal to 0. Okay, so we'll move on to the next one. It's a very simple problem, 10 mark question. Expand log x in the powers of x minus 1 by Taylor's theorem and hence find the value of log 1.1 correct up to 4 decimal places. So what Taylor's theorem says, for Taylor's theorem, your f of x has to be continuous and all its derivative exists. Then f of x can be expressed in the neighborhood of a. Yes or no? F of x can be expressed in the neighborhood of a as an infinite series. F of x can be expressed in the neighborhood of a as an infinite series of um, as an infinite series, right? Okay. So what Taylor's theorem says is, so what Taylor's theorem says is your f of x is continuous f of x is continuous and the derivative exists at all points, and derivative exists at all points, then this f of x can be expressed in the neighborhood of a as follows. Exists in all points, then your f of x, then f of x can be expressed in the neighborhood of a. F of x can be expressed in the neighborhood of a as follows. So f of x is equal to f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial x minus a whole square plus f triple dash of a f triple dash of a by 3 factorial x minus a whole cube and so on, right? So f triple dash of a, x minus a, f dash of a by 1 factorial x minus a whole square, f double dash of a by 2 factorial and so on, right? Now you just have to expand your function f of x is log x. You just expand in the neighborhood of 1, right? Uh, you just apply Taylor's theorem, for f of x is equal to log x around 1, right? Around the neighborhood of 1, right? Now if you put a is equal to 1, then you can see we can express log x in the powers of x minus 1, right? Because you can see if a is equal to 1, we will get x minus 1, x minus 1 whole square, x minus 1 whole cube. So we can expand log x in the power of x minus 1. If you expand log x around x is equal to 1 in the Taylor's theorem. Yes or no? Very simple, right? So you just expand f of x equal to log x around x is equal to a, right? About x is equal to 1. So about, around, or about, we will write about instead of around. About neighborhood of 1. Neighborhood of x is f of x can be expressed in the neighborhood of a as follows. Okay, so you just put a to be equal to 1. Then this f of x will be equal to f of 1 plus f dash of 1 by 1 factorial x minus 1 plus f double dash of 1 by 2 factorial x minus 1 whole square plus f triple dash of 1 by 3 factorial x minus 1 whole cube and so on. You can see we have expressed f of x in the powers of x minus 1. Here the power is x minus 1 whole power 0. Okay. Now we need to find f of 1, f dash of 1, f double dash of 1, f triple dash of 1 and so on. That we will find now. So your f of x is log x. What is your f dash of x? F dash of x is 1 by x. What is f double dash of x? Derivative of 1 by x is minus b into u dash minus 1 by x square, and f triple dash is 2 by x cube, right? So all these are very basic. So I'm assuming that everyone knows how to differentiate a function, right? You will have 1 by x minus 1 by x square, and then we have 2 by x cube. Now what will be my f of 1? So f of 1 is log 1. So log 1 is 0. So what will be my f dash of 1? It is 1. And what will be my f double dash of 1? It is minus 1. And what will be my f triple dash of 1? It is plus 2, right? This will go on and on. So that means this f of x can be written as f of x is log x, right? Log x. What is f of 1? F of 1 is 0 plus f dash of 1. So 1 into x minus 1 plus f double dash of 1 into x minus 1 whole square plus f triple dash of 1. So 2 by 3 factorial into x minus 1 whole cube and so on. So we have expressed log x, right? We have expressed log x as x minus 1, x minus 1, x minus 1 minus 1 by 2 x minus 1 whole square plus 1 by 3 x minus 1 whole cube and so on. So we can see we have expressed log x in the powers of x minus 1 by Taylor's theorem. Is it clear up to now? And hence find the value of log of 1.1 up to 4 decimal places, right? So you just expand, you just put x is equal to 1.1 here. Now to find log 1.1, to find to find log 1.1, put x is equal to 1.1. So we know log x can be expanded as x minus 1. See, 1.1 is in the neighborhood of 1. So that means I can apply this. Put x as 1.1 is in neighborhood of 1 also, right? So log x will be, so it will be approximated to log of, we know log x expression is what? X minus 1 minus 1 by 2 minus 1 by 2 x minus 1 whole square plus 1 by 3 plus 1 by 3 x minus 1 whole cube and so on. Okay, just put x is equal to 1.1. So log 1.1 is approximately 1.1 minus 1 minus 1 by 2, 1.1 minus 1 square, 1.1 minus 1 whole cube and so on. So this is approximately 0.1 minus 1 by 0.1 square plus 1 by 0.1 whole cube and so on. See, you can, after this or after some stage, this value will be very closer to 0. So you can neglect those values, right? You can neglect those values. So after this simplification, the value will be 0.0953. 0.0953. I'm not going to do this, right? We just simplify this. You'll be getting this value to be approximately 0.0953. Is it clear? Can you move on to the next one? Okay. So very simple, right? So we have expanded just applying Taylor's theorem for log x in the neighborhood of 1. So we'll be getting log x in the powers of x minus 1. After that, you put x is equal to 1.1, you will get the value of log 1.1. Okay. So first question is based on continuity. Second question is based on Taylor's theorem. We'll move on to the third one. Okay. If u is equal to x plus y and v is equal to tan inverse of x plus tan inverse of y, then find dou u comma v by dou x comma y. Are u and v functionally related? If yes, find the relationship between u and v. By seeing at the question itself, u and v are related. Yes or no? See, you just compare this with linear algebra of linearly dependent, linearly independent. Just compare that. When two vectors are linearly dependent, if one can be expressed as the other. Yes or no? One can be expressed with the help of other vector. When two vectors are linearly independent, one cannot be expressed in the one cannot be expressed with other vector. Right? Two vectors are linearly independent if one cannot be expressed with the other vector. You similarly, two functions are related if one can be expressed as other. Just compare with linear dependence. Right? Two functions are not related if one cannot be expressed as other. Just compare that with linear independence. Right? So in linear algebra, when two vectors are linearly dependent, or when some vectors are linearly dependent, uh, in accordance with the determinants will be equal to 0, right? then only rank will be less than number of variables. Now similarly, here two functions are related if this Jacobian is 0. But by seeing the question itself, I can say these two are related. How? See, what is tan inverse of x plus tan inverse of y? What is tan inverse of a plus tan inverse of b? Tan inverse of x plus y by 1 minus xy, right? So you can see our b is tan inverse of x plus tan inverse of y. Now what is tan inverse of x plus tan inverse of y? Tan inverse of x plus y by 1 minus xy. Basic inverse trigonometric function formulas. Now tan inverse of what is x plus y by 1 minus xy? That is equal to u. This is b. So that means tan b is equal to u. That means u and b are related, right? If I know b, I can find u. Yes or no? If I know v alone enough to find u because u is nothing but tan v. That means these two are related, right? So by looking at the question itself, I can say these two are related. If yes, find the relationship. This is a relation between u and v, right? But uh, mathematically, we say that these two are related if this Jacobian is 0, right? So u and u and v are, see, u is a function of x. V is also a function of x. U is a function of x comma y. U is a function of x comma y. V is a function of x comma y. We will find dou of u comma v by dou of x comma y. What is this? Determinant of dou u by dou x, dou u by dou y, and then dou v by dou x, dou v by dou y. So if you find the determinant, if it is equal to 0, then we say, if it is equal to 0, then we say u and v are functionally related. Just compare this with linearly dependence. U and v are functionally related. Now we will find all these values now. See, here it is partial derivative only, not the usual differentiation. It is nothing but a partial derivative. So you know how to differentiate a function partially. So we have u is equal to x plus y divided by 1 minus xy. Now what is dou u by dou x? We'll differentiate this partially with respect to x. So v into u dash. Now x plus y, you have to differentiate partially with respect to x. It will be 1 plus 0. You differentiate partially with respect to x, derivative of y will be 0. Differentiate partially. If not, you will have 1 plus dy by dx. But here we are differentiating partially. So b into u dash minus u into b dash, derivative of this. Derivative of 0 is 1. Now xy you have to differentiate with respect to x. That means you can treat minus y as constant. Derivative of x is 1 whole divided by 1 minus xy whole square. So this will be what? 1 minus xy minus x minus y. This will be plus xy minus y minus y. It will be plus y square whole divided by 1 minus xy whole square. So your dou u by dou x will be 1 plus y square divided by 1 minus xy whole square. Now you find dou u by dou y. So b into u dash with respect to partially you differentiate with respect to y. So derivative of x is 0, derivative of y is 1, right? Minus b into u dash, you differentiate 1 minus x with respect to y. So your minus x will be constant, derivative of y is 1 whole divided by 1 minus xy whole square. I'm applying quotient rule. So this will be equal to 1 minus xy minus plus x square plus xy whole divided by 1 minus xy whole square. So this will be 1 plus x square divided by 1 minus xy whole square. This will be my dou u by dou x, dou u by dou y. Now similarly, we have v is equal to tan inverse of x plus tan inverse of y. So you differentiate partially with respect to x. So this will be 0. So derivative of tan inverse of x is 1 by 1 plus x square, and dou v by dou y, right? Dou v by dou y will be 1 divided by 1 plus y square, right? Now find dou of u comma v by dou of x comma y. Dou of u comma v divided by dou of x comma y. So which is dou u by dou x, dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. So which is determinant of, so dou u by dou x is 1 plus y square divided by 1 minus xy whole square. Dou u by dou y is 1 plus x square divided by 1 minus xy whole square. Dou v by dou x is 1 divided by 1 plus x square. Dou v by dou y is 1 divided by 1 plus y square. So this will be, if I multiply this, you will have 1. You multiply this 1 plus y square by 1 minus xy whole square into 1 divided by 1 plus y square minus 1 plus x square by 1 minus xy whole square into 1 divided by 1 plus x square, right? So this will be 0, right? This will be 0. So this will be 0. That means u and v, I can say u and v are functionally related, right? I can say u and v are functionally related, right? Okay. Now, what is the relation that we already found, right? Relation is given by the relation between u and v is given by. So we already know, right? What is u? U is x plus y by, u is x plus y by 1 minus xy, and v is tan inverse of x plus tan inverse of y, so which is equal to tan inverse of x plus y by 1 minus xy. Just applying formula. This is tan inverse of u. That means we have tan v is equal to u. So u is equal to tan v. So if I know v, you just apply tan for v, you will get u. That means these two are functionally related, right? Is it clear? So we'll move on to next one. Okay, so we'll move on to next one. Is it clear up to now? 28 minutes. Okay. So all these are very simple problems based on Jacobians, so partial derivatives. That is 15 marks. By seeing at the question itself, you can see it related. If you know the basic formulas of tan inverse of a plus tan inverse of b. Okay. Using integration, find the area lying inside the cardioid r is equal to a into 1 plus cos theta, and outside the circle r is equal to a. Again, very simple problem. Just a minute. Okay. So using integration, find the area of, a minute. Okay. So using integration, find the area lying inside the cardioid r is equal to a into 1 plus cos theta, and outside the circle r is equal to a. So double integration we will do by polar coordinates. So for double integration, the polar coordinates is x is equal to r times r cos, x is equal to r cos theta, and y is equal to r sin theta, right? That is x comma y we are representing in terms of r comma theta. So it will be a polar coordinates, right? In terms of polar coordinates. Okay. Now you know the this is a cardioid. R is equal to a into 1 plus cos theta. Very standard diagram. R is equal to a into 1 plus cos theta. So this will be 2a. Will be, let us say this a. This will be a again. This will be a. So it will be like this is 0. So right. So this is the graph of cardioid. Standard graph, right? Very standard graph. So this is the graph for cardioid. R is equal to a into 1 plus cos theta, right? This is a, this is minus a, and this is 0 and 2a. Now we have our cardioid. R is equal to a into 1 plus cos theta, and then we have a circle, R is equal to a. So we will write this in a general equation of circle. So we have R is equal to a. So that means R square is equal to a square. And you know what is R square? It is nothing but x square plus y square is equal to a square. Yes or no? Just square and add. So x square plus y square will be r square sine cos square theta plus r square sine square theta. You just take r square common. So x square plus y square is r square. So we can see this is a circle with a center 0 comma 0 and the radius is a, right? Center 0 comma 0 and the radius a. So r is equal to a is nothing but center 0 comma 0 circle and the radius is a. So center 0 comma 0 and the radius is a. So just draw that circle also. So we have a minus a. Let us say this is your minus a this side. So we'll be having, I think circle is very difficult now. You just have to connect these two, right? You just have to connect these two and then you form a circle. So just a minute, I'll make use of tool to draw the circle. Just a minute. Draw this. First I'll draw this roughly. Right. So adjust this. This is the circle. This is a circle. R is equal to a, right? This is the circle. R is equal to a. This is a circle. R is equal to a. Now, what we need to do is we need to, using double integration, find the area lying inside cardioid and outside the circle. So what is it? Inside cardioid and outside the circle. What is the region actually? Inside the cardioid and outside the circle. Inside the cardioid and outside the circle. This is a region, right? Is it clear? Actually, diagram circle will be R is equal to A, right? The circle, I think diagram I made some error for circle because To draw like this, you will have some other area also, right? Inside and outside. I'll just I'll just rearrange this diagram. I drawn this part very big. Okay. So the exact diagram will be go like this. Right. This is minus A and this is A and A. This is circle. Yeah, all the standard problems, right? Don't think it is new. They asked from different world. Very simple. All are very basic problems of double integration problems. So we have R is equal to A, and then we have a cardioid. Yes. So this is 2A, and A. Yes. This is the graph for these. Yeah, we need to find the area lying inside the cardioid and outside the circle. So this is the region, right? So we'll do this problem. So our required area is we will consider only this region first, right? We will consider only this region. So we will find this area. Both are symmetrical about the x-axis, right? So we will find this area alone. So area is 2 times of integration of r dr d theta, right? So this is the formula for double integration in polar coordinates. R times dr d theta. R times dr d theta. So very simple. You just find the limits for r and theta. So this is 2 times integration of r times dr d theta. Now where theta varies, so you can see theta varies from 0 to pi by 2, right? This is 90 degree. So your theta varies from 0 to pi by 2. So your theta varies from 0 to pi by 2, right? Theta varies from 0 to pi by 2. And where your x varies, your x, see, you can see we are finding this region. So here you can see where your r varies. So here r is equal to a for this, and here r is equal to a into 1 plus cos theta, right? So you can see your r varies from a to 1 plus r cos theta. R varies from a to r varies from a into 1 plus cos theta. So just you have to find the limits for r and limits for theta. Now integrate this, you'll get the answer. So this is 2 times of integration of 0 to pi by 2. So integration of r dr is r square by 2. So 1 by 2 r square. R varies from a to a times 1 plus cos theta into d theta. So this 2 will get cancelled. I'm putting 2 because I'm finding only this part and then I'm multiplying by 2. So this will be integration of 0 to pi by 2. Integration of 0 to pi by 2 a into 1 plus cos theta whole square minus a square d theta, right? So this is integration of 0 to pi by 2, integration of 0 to pi by 2 a square. So 1 plus cos theta whole square is a square plus b square plus 2ab, and then we have minus a square d theta. Now we multiply a inside, so this a square and this a square will get cancelled. So we have this to be equal to integration of 0 to pi by 2. Just a minute. Okay. So you just multiply this a square inside. So you will have a square cos integration of 0 to pi by 2 a square cos square theta, a square cos square theta plus 2a square cos theta plus 2a square cos theta d theta. So integrate this, you will get the answer. So this a square and this a square will get cancelled. So this will be, now you just take a square. So integration of 0 to pi by 2 cos square theta plus 2a square integration of cos theta d theta integration of 0 to pi by 2. So you will have a square. So integration of what is cos square theta? 1 plus cos 2 theta by 2. So 0 to pi by 2 plus 2a square. So integration of sin is cos sin. This is sin theta 0 to pi by 2, right? So this will be a square by 2. So this will be a square by 2 d theta plus a square by 2 integration of cos 2 theta 0 to pi by 2 plus 2a square sin pi by 2 is 1, right? So this 0 to pi by 2. So we have this to be a square by 2 pi by 2, and then here we have a square by 2. So integration of cos 2 theta sin 2 theta by 2 0 to pi by 2 plus 2a square. So this will be pi a square by 4. And here we have a square by 4 um, sin 2 pi by 2 minus sin 0. So this full term will be 0, I think, right? Integration of cos 2 theta is sin 2 theta by 2. So when you put upper limit, you will have sin 2 pi by 2. So which is sin pi. Sin pi is 0. And then we have sin 0, which is 0 again. And then we have 2a square. So um, pi a square by 4 plus 2a square. So pi a square by 4 plus 2a square will be your answer, right? Or is there any mistake I have made? Or else we can, in the key they have given that a square by 4 pi plus 8. Yes, no problem. So you just multiply this 4 here. So pi a square plus 8a square by 4. So just take a square outside. So a square by 4 5 plus 8. So a square by 4 5 plus 8 is your required area, right? A square by 4 5 plus 8. So very simple. You just have to using double integration find the area lying inside the cardioid and outside the circle. So you just have to draw the diagram correctly. First I have drawn like this. You draw like this means you will have this area also common, this area also common, right? You just understand cardioid will be this will meet at 2a, a and 0, right? And this will be, this point will be less than a, right? Without I forgot that, and then I drawn this inside. So this point will be less than a. So you just draw a circle, and then you can see outside the circle, inside the cardioid. Outside the circle, inside the cardioid. Now you just find only this part, right? You find this part, and then you multiply 2 times. So this part is here r, where is r is equal to a, and here r is equal to a into 1 plus cos theta. And here theta varies from 0 to pi by 2. So for r limit, r a to a into 1 plus cos theta, and theta varies from 0 to pi by 2. I'm multiplying 2 times because I'm finding only this region. I'm multiplying by 2. Is it clear? So we'll move on to the last problem, which carries 20 marks. It is nothing but a 20. It carries 20 mark, which is nothing but a 10-mark question in 12th standard. So every time we'll get the question in 12th standard. Can you recollect this? In 10th standard, there will be, sorry, 12th standard, there will be a concept of maxima minima, and then with the help of the application of maxima minima, you will be always getting one problem in 12th standard CBS or state board or any board you are studying, right? there will be many standard like volume of cone is 4 by 27 of volume of 8 by something for volume of sphere, and then there will be many volume, right? We are inscribing and this in this prove that it has a maximum volume, like that of problem you'll always have one in a 12th board, right? So that board question, actually these are very standard 12th standard question. So what they have asked is find the volume of greatest cylinder which can be inscribed in a cone of height h and semi-vertical angle alpha. So we need to find the volume of greatest cylinder which can be inscribed in a cone of height h and semi-vertical angle alpha. So semi-vertical angle is this, right? Right. So this is where semi-vertical angle alpha for a cone, and we have given that find the volume of greatest cylinder that can be inscribed in this cone with respect to semi-vertical angle alpha and height h. So we have the height of the cone is h, right? Height of the cone is h. They have given. Uh, let 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 height of let the height of cone be h, right? They have given, and semi-vertical angle be alpha, and semi-vertical angle alpha. So for cone we have alpha semi-vertical angle height as h. So let x be the radius of cylinder. Let x be the radius of cylinder, and let us assume capital H be the height of cylinder. Capital H be the height of cylinder, right? So we have x to be the radius of cylinder. That means this is x, right? This is x. This is also x, and this is h, right? Height is capital H. So the height of cylinder is capital H, and height of the cone is small h. And for a radius of this cylinder is uh, small x, and semi-vertical angle of cone is alpha. So we need to maximize this volume. What we need to maximize? We need to maximize the volume of cylinder. So we need to maximize. So we need to maximize the volume of cylinder. See, we need to use that semi-vertical angle alpha and h only. For that cone, we know only semi-vertical angle alpha and height. So we need to maximize the volume of cylinder. So what is volume of cylinder? Pi r square h. So r is x, height is h. Pi r square h is your volume of cylinder. R is the radius of cylinder. Radius is x and height is h. Okay. Now we will find h, right? We will find h, but we don't know what is h it is. We don't know h. We will find h. So let us call this as A, call this as B, call this as C, and let us say this point is M, right? Let us say this point is M, and let us say this point is C. Let us say this point is D. Now in right angle triangle AMC, in right angle triangle AMC, what is tan alpha? Tan alpha is opposite by adjacent. So opposite is X, adjacent is AM. Yes or no? This is a right angle triangle, right? In this right angle triangle, what is tan alpha? X by AM. So your AM is X by tan alpha. So that means I can write AM as X into cot alpha. AM as X into cot alpha. So this distance AM is X into cot alpha, right? This AM distance is X into cot alpha. Then what about this capital H? What about this capital H? Capital H is whole height minus AM, right? So capital H can be found by whole height is H minus AM. Yes or no? Yes or no? This is our capital H. This is height of the cylinder, which is equal to total height minus AM. So I can write this as pi x square h is small h minus AM. Small h is the from the height of the cone. You subtract AM, you will get the height of cylinder. Okay, so this will be pi x square h minus AM. So pi x square h minus what is AM? AM is x into cot alpha. This is the volume of cylinder with respect to that semi-vertical angle alpha and height h for cone. I'm bringing the constraints here with respect to that, right? We know only semi-vertical angle alpha and the height of the cone. Okay. Now we need to maximize this. Very simple, right? So find critical points. Find critical points. So we will find dv by dx is equal to 0 because maximum only occurs at critical points, right? Maximum or minimum occurs at critical points. So dv by dx is equal to 0. So d by dx of d by dx of pi h x square pi h x square. I'm just multiplying this minus pi x cube minus pi x cube cot alpha is equal to 0. So pi h is constant. Derivative of x square is 2x minus pi cot alpha is constant. Derivative of x cube is 3x square is equal to 0. Right. So we have 2 pi hx is equal to 3 pi x square cot alpha. I can cancel one x because x is non-zero here. Because x is non-zero. I can cancel this because x is non-zero. Why x is non-zero? Because if x is 0 means you will not have cylinder at all. Because x is the radius of cylinder, right? X is the radius of cylinder. So x is not equal to 0. So that means you can cancel one x. If not, you cannot cancel. If you are cancelling two things, you have to make sure that both are non-zero and same. Okay. Now this reduces to can also pi also can cancel. So we will have 2h is equal to 3x cot alpha. So x will be 2h by 3 cot alpha, right? So x is equal to 2h by 3 cot alpha is your critical point. So maxima or minima? Sorry, not feeling well. I think. Sorry. So x is equal to 2h by 3 cot alpha. Okay. So this is your critical point. Now at this point you will have either maxima or minima. Now we need to show at this point this has maxima. Then only you can say that the maximum volume of rotor cylinder which can be inscribed in a code. We need to find the volume of rotor cylinder. Okay. So we will show that when x is equal to 2h by 3 cot alpha, we show our function v as maximum. So for that, you find second derivative. So what is your dv by dx? What is your first derivative? This is your first derivative, right? That is 2 pi h 2 pi hx 2 pi hx minus 3 pi cot alpha x square. This is your first derivative, right? Now you differentiate once again d square v by dx square. This will be 2 pi h minus 3 pi cot alpha into 2x. Okay. Now at x is equal to, we substitute this critical, you know how to find maximum minima, right? You substitute the critical point in second derivative. If that is less than 0, it is maxima. Greater than 0, it is minima. I'm assuming everyone knows the basic idea of maxima minima. So at x is equal to 2h by 3 cot alpha, you substitute here x is equal to 2h by 3 cot alpha. We see that d square v by dx square will be less than 0. Yes or no? Right? See, or else you can also substitute this cot alpha to be 3x by 2h. Right? You substitute this cot alpha to be 3x by 2h, so that you will have everything in terms of h. If you don't want cot alpha here, wherever you see cot alpha, you substitute 3x by, okay, here I'm saying. Okay, anyway, so you substitute here and simplify. So obviously you'll be getting less than 0. So that means at x is equal to 2h by 3 cot alpha, it has maxima. It has maxima. So therefore, at this point, the function will have maximum value. So therefore, the volume of cylinder will be maximum when x is equal to 2h by 3 cot alpha. Now, what is volume of cylinder? Pi x square into h minus pi x square into h minus x cot alpha. This is your volume of cylinder, and this will be maximum when x is 2h by 3 cot alpha, because 2h by 3 cot alpha is your critical point. At this point, the second derivative is less than 0. That means it has maxima. So substitute that point here. So pi times x square is 4h square by 9, h minus 2h by 3, 2h by 3, x minus x is 2h by 3 cot alpha only, right? Or I made mistake, any mistake? X is 2h by 3 cot alpha only, right? 2h by 3 cot alpha. We are getting cot square alpha. What's our x? Just a minute. Pi x square h minus x cot alpha. So x is 2h by 3. X is 2h. Okay, it is tan alpha, I think, right? 2h by 3. X is 2h by 3 tan alpha, right? X is 2h by 3 1 by cot alpha. This is, sorry, this is tan alpha, right? Just a minute. I think slow easily I have solved. Just a minute. Yes, your x is 2h by 3 tan alpha, right? 2h by 3 1 by cot alpha. 2h by 3 1 by cot alpha. So this will be 2h by 3 tan alpha. Sorry. So 2h by 3 tan alpha is your critical point. Now I think this will be easily get cancelled now. 2h by 3 tan alpha. Now you substitute x is 2h by 3 tan alpha. Tan and cot will get cancelled. Now it is very easy to prove. It will be less than 0. This is tan alpha. Sorry. So 2h by 3 tan alpha. Right? You just substitute this 2h by 3 tan alpha. Tan and cot will get cancelled. You will be having a number that less than 0. Okay. Remember that your x is greater than 0 and h is also greater than 0. So this is pi times. So x square is 4h square by 9 tan square alpha, h minus x is 2h by 3 tan alpha into cot alpha. So we will have 4 pi h square, 4 pi h square by 9 tan square alpha. So these two will get cancelled. So 3h minus 2h is h by 3, right? So if you simplify, what you will have? 4 pi h cube by 27 tan square alpha, right? 4 pi is correct. 4 pi h cube, 4 pi h cube by 27 tan square alpha. This is your maximum volume of cylinder if the semi-vertical angle is given by alpha for the cone and height is h. So find the volume of greatest cylinder. The volume of greatest cylinder is 4 pi h cube by 27 tan square alpha. This you can prove, right? You just substitute this point here, right? Instead of 2 times x, so just substitute 2 times 2h by tan alpha. This will get cancelled. You simplify, right? You will be getting all quantity to be less than 0, make use of x is greater than 0, x is greater than 0. So we'll be getting this all quantity to be less than 0. So that means at this point it will have maximum. Now for maximum value is you substitute the critical point in the function. So 4 pi h cube by 27 tan square alpha is the volume of greatest cylinder. Is the volume of greatest cylinder that can be inscribed in a cone of semi-vertical angle alpha and height h. Right? So that's it. So we have completed 5 problems. See, very simple problem. This carries 20 marks. You can do this in 5 to 6 minutes. Right? See, there are some standard 7 to 8 problems based on application of maxima minima. You just go to the playlist. I have solved the same problem there also. In the calculus playlist, I think calculus 07, I think 7 I think. I have solved the same this problem there also. I have solved some 7 problems based on application of maxima minima. You see that 7 problems. If they are asking from application of maxima minima, there is a high chance that it will be from one of those 7 problems, right? I already solved the same problem there also in a playlist, calculus playlist. Okay, so sorry for this, right? I wasted some 1 or 2 minutes. It's 2h by 3 tan alpha. Okay, so we have started with the first problem, which is discuss the continuity of the function. Very simple problem, 10 mark. So you can do this in 2 to 3 minutes if you are good in concept. Again, 10 marks. You can do this in 3 to 4 minutes. 10 marks, 20 marks, and then again very simple 15 marks. You can do this in 3 to 4 minutes again, and then using double integration. Just you have to see there are some standard graphs that I'll explain when I'm doing concept videos. A into r is equal to a into 1 plus cos theta. R is equal to a into uh, 1 minus cos theta. So there are some standard problems, standard graphs, so that I'll explain when I'm doing concept videos of calculus. So again, if you have this circle, how to transform that to general equation at all, that tip I'll give you when I'm doing concept videos of this double integration. Right. So this problem again very simple. You just have to make use of double integration to find the area. And then fifth problem, standard problem, 12th standard level problem. So easily you can get 70 marks, right? So the next class we will solve 2023 solutions of calculus. So thank you. All the best.